Hello everyone. In this video, we are going to start with A2 forces and momentum. This will be a three-part video where we are going to cover about forces in the first part, and then we are going to talk about circular motion, and then we are also going to cover the momentum part of the chapter. So overall, we will have three parts. So in this part, we are going to cover with forces. Okay. According to the syllabus guide, we have Newton's laws of motion, how the forces interacted, free body diagram, then nature of forces, different types of forces. We have additional few forces and the formulas, how to calculate them. Then we have circular motion and momentum in detail. All those things will be covered in the next part of the video. So let's start with Newton laws. So we have been aware of Newton laws in the earlier grades. Just to refresh it, a Newton law, according to Newton's law, the first law says that if the resultant force acting on an object is zero, resultant force means a combined effect of a force. So if there are multiple forces acting, uh, the force combined them should cancel out each other. So I can say that this is a resultant force is zero, or I can say that no force is acting on an object. So that is also a case where the resultant force is zero. Okay, or we can also say that the forces cancels out each other. Forces are balanced. So in this condition, what happens is like the object is stationary, then it will remain stationary. And if the object is moving, then it will move with a constant velocity such that the acceleration will be zero in this situation. So whenever acceleration is zero, or the object is moving with a constant velocity, we always consider all the forces, vertical or horizontal forces, are balanced. So that's the Newton's first law. The second law suggested that the resultant force, if the forces are imbalanced, there will be a resultant force in a particular direction. So if a resultant force acting on an object is equal to the mass time acceleration, in this case, we can write as net force is equal to mass time acceleration. So here is most important part is the net force. It is not just any force is equal to mass time acceleration. It's the combined effect of an object, because object, no matter how many forces are acting, it is going to accelerate in one direction only. So in the direction the object is accelerating or it is moving, so that's the direction in which the resultant forces and the combined effect of all the forces has to be in the direction of the resultant forces. Okay. Now there are a lot of misconceptions regarding Newton's third law. We'll try to understand it in much more deeper sense. Okay, so everybody knows that Newton's third law is every action has equal and opposite reaction. But I like to go in much more detailed sense so that we can understand fully what it means and what it does not mean. Okay, so if the object is experiencing some kind of a force from some other body, okay, it is always the two objects, two bodies that are applying force on each other. So if I'm experiencing any force from some other body, then the body itself will experience equal and opposite force in the opposite direction from the object. So if a certain kind of a body is applying force on some object, that object will also apply the same equal and opposite force on the body itself. Now this is very like it sounds very similar to the previous statement where that every action is equal and opposite reaction. But when we talk about forces, forces acts in an action and reaction pair. So if I give you an example, let's say I have kept a book on a table, and the upward acting force on this book is normal force, and the downward acting force is the weight force. Now, in most of the scenarios, students think that the normal force and the weight is action and reaction pair because both are in opposite direction and both are equal. But let me tell you, this is not true. Okay, action and reaction pair are the forces of same type, or the nature of the force is same. Why is that mean? It means that no, let's say in an action force, weight we are concerned. Now weight is applied by who? It is weight is not applied by the table. The weight is the force experienced by the book due to the gravity of the earth. Who is applying the downward force on the book? It is weight. It is the earth that is exerting a force downward. So the reaction must be, so the force is between book and the earth. So As a reaction force, Earth should experience a upward force from the book, due to book, not from the table. So the nature of this force is gravitation in both the cases. So whether the book is attracting us or Earth is attracting book, it should be same. So weight has a reaction force that the Earth is experiencing an upward force towards the book. Now, definitely, book is much lighter or has a negligible mass in comparison to the mass of the Earth. So Earth does not move in any sense, okay, because of the book. But it is true that there is force acting on the Earth. Similarly, the normal force is exerted by the table on the book. So table is applying the force. So in this case, the table should experience a downward force from the contact to the book. So this is the where clarification is needed, where the nature of the forces needs to be set, and you need to always specify who is applying force on who, and that force, the pair will always experience the action reaction uh, from each other. So that is where we need to clarify. It is just because the forces are opposite and equal does not mean their action reaction pair. Okay, I have another example. Imagine there is a rocket that is going upward. Now rocket is experiencing an upward force from the engine, but because the engine is pushing down all the masses, like a fuel is bursting out of the bottom of the rocket, and the weight is acting downwards. So in this case, the action pair is the force due to engine. This is caused by the fuel. So the reaction pair is the fuel is experiencing a downward force. That's the fuel coming out at the bottom. Similarly, weight is downward force caused by the earth. So earth will experience an upward force due to rock. So it is just because the forces are not are equal and opposite doesn't it mean that they are action reaction pair are specifically between two objects, okay, and we have to always identify on between which two objects, and action reaction pair always acts on two different objects. In both the cases you will see that if the action pair is the force on engine, it is applied on the rocket, then the reaction pair is not applied on the rocket, it is applied on the something else like a fuel, or in the reaction pair like on the earth, the weight is acting. So we have to always be ensure both the forces are of same type and act on two different objects. We have to be sure about that. Okay. Next is the type of forces. We will quickly go through all the types of forces. So we are aware of force type like weight. Weight is given in mass times gravity, and the gravitational acceleration on Earth is 9.8, but it can be any value meter per second square. Okay, uh, it can change. So as per that, the weight will change, but the mass remains same. This is something that we are aware of. Then we have tension. So tension is the force that is experienced by an object that is attached with a string. So the object experiences tension whenever we pull an object with using some kind of string. Now one rule is if there is a one string attached to multiple objects, let's say there is only one tension. So here, if there are two blocks and there is one string between them, and you can see that there is only one tension. So tension is always applied in the direction of the string. And here you can see that if the string is experiencing a downward tension of T, then the other end of the string should also experience the same. Now, in this case, this is much more important assumption. We assume that the string is massless. Okay, if the string has some kind of a mass, then we can't consider one string is equal to one charge. Okay, so this is very important assumption. The third force we are going to talk about is the normal force. A normal force, sometimes they are also called as uh, reaction force. Okay, so these are the similar names, sometimes given as capital R as well. So it is a force between the objects that are in contact with each other, or it can be object or a surface. It is some kind of a contact force. Okay, it depends on the material of the surface and the object itself. Okay, now one thing that we like to note about a normal force that it is always perpendicular. What we are observing here, it is always perpendicular to the point of contact. So, whether it is if the ground is like this inclined, so the normal force will be perpendicular to the ground. Also, one more mistake that shouldn't do if there are multiple objects, let's say, for example, the block here in the middle is experiencing two contact forces, one from the ground, so that will be upward, okay, and one from the box above. So these are the two forces. So if the object is in contact with n number of surfaces, then it will have n number of normal forces. So that is something that we need to care about. It is not just from normal forces, always from the ground. It can be from the other objects as well that the object is in contact with. And it can be like vertical, it can be horizontal, it doesn't matter. Wherever there is a contact, there will be some kind of a normal force between the objects. Okay. So, and as per the Newton's third law, we should know that if the box is applying this much force on the bottom box, then the same box will experience the upward force. This forces are equal as per the Newton's third law because this is the forces between those two boxes. Okay. Then we are going to talk about another force, that is friction. So friction is very special. Friction always acts in the opposite direction of the possible motion. And as I say possible motion, it doesn't mean that object needs to move it. If for a stationary cases, we have a static friction. For a moving object cases, we have dynamic friction and dynamic, kinetic, whatever we can call. But it is in the direction of possible friction. What does that mean, possible? Like imagine in the case where the object is not moving. Just you have to imagine that what if there was some kind of a oil between the two surfaces. Like let's say I have a object that is on the inclined plane, but it is stationary. Okay. So in what direction it must be experiencing a friction force? So normally, if there was no friction, this object will have slided down. So friction has to be preventing it in opposite direction. We have to so possible motion is downwards. Okay. So even if it is stationary, the possible motion, it has to be in opposite direction of the possible motion. That is something that we need to aware of. The friction is given as F into mu into N. So mu is coefficient of friction, okay, and N is the normal force. So it is proportional to the normal force. If the object is not in contact, there will be no friction, obviously. Okay. So then we have two cases of static friction. So static friction is a friction that is applied on object when it is stationary. It increases its properties, it increases with the applied force. So more and more force is applied, the static friction keeps on increasing until a max value of static friction is reached. Okay, until once you reach the maximum value, then the object starts moving and becomes into dynamic friction cases. Okay, but till then you get this value. So you need to understand that whenever they give you value of coefficient of friction for static coefficient, it is like a max value. Okay, so max static friction that we calculate in most of the cases. So it is a variable quantity. It changes from 0 to 1. Okay, so that is something that we need to aware of. And then dynamic friction is a constant force. So no matter how much you apply, there will be, regardless of applied force, it will remain constant. It can calculate by this. Okay. Then there is a air resistance. Air resistance is another kind of a resistive forces. So it is also acts in the opposite direction of the possible motion. So whenever we apply force, like air resistance, it can be moving through air. So read the question. If the object is saying that it is moving through air, always consider air resistance. Okay. Now, whenever there is a air resistance, it will be like proportional to velocity. So as the velocity will increase, the air resistance will increase. Okay. So we can have a relationship like F is equal to alpha V or F is equal to kV. But this relationship is not given in data book. It is not true in every case. Sometimes it can be F is directly proportional to V square also. So this is just an example where K is just some proportionality constant. It does not have any particular. It can depend on surface area of an object. If the surface area increases, the air resistance also increases. So velocity and surface area are the two important properties of an object that will tell us how much air resistance it will experience. And the Direction of motion is also very much important, which also tells us what is the direction of the air resistance as well. Okay. Then another kind of a resistive forces is the Stokes law, Stokes force, drag force. Okay. So this is for the drag force. So drag force comes in different ranges like friction, aeration, all the different kinds of drag force. But we are in the Stokes law, we are going to learn specifically about a object, a spherical object that is moving of a radius r and a mass m, that is moving through a fluid which has a viscosity of n with velocity v. Now this velocity in most of the cases is terminal velocity. Okay, so we need to aware of that part as well. So imagine there is an object like a falling at velocity v inside a liquid. Okay, so in that case, the formula gives us Fd is equal to 6 pi eta r eta v. Okay, so this n is like eta. Okay, it is a Greek alphabet, not like n. So it is given like this. Okay, and it represents viscosity. Now, what does it mean by viscosity? Viscosity uh, say tells us about how thick or how easy the fluid flow over a surface. Like a water has very low viscosity. Okay, water, something like a water will have very low viscosity, and something like a honey, if you make it slide down a slope or something like that, it has very high viscosity. So it is just a coefficient of viscosity it might be. So this Stokes law is very much newly added to the syllabus, so we just have to be uh, like we will see a couple of examples for how it will be used, but in most of the cases it will be very straightforward. You just have to be aware that if there is a spherical object, and this is only applicable for spherical objects. So if there is a spherical object that is moving through a fluid at some velocity v, then it can give us drag force, and drag force is always opposite direction of the motion of an object. Okay. Then another force we have is the buoyant force. So buoyant force is also newly added forces. The buoyant force, if there is some kind of a object that is floating on a water, then there is upward buoyant force. It cannot like it do not have to be water. It can be any fluid like liquid or gaseous. Okay, where this rho sign is for the density of the fluid, and the VIM is the volume of immersed part of the object. So this is very important. We don't have to take the volume of entire object; it's just the volume of immersed part. So in this case, this part is immersed. So we will only consider that much volume of the entire object because that is the amount of or volume of water displaced. So this has to be equal to amount or volume of water displaced by the object. Okay, so this is clear. So then, and G is just a gravitation. Okay, uh, then we have the weight. Now, weight in most of the cases related to buoyancy related problem. Instead of giving the mass, they give us the density of the block or some object. Now, density times VB means mass can be replaced by density into volume. Now, here the density is not the density of the liquid, but the density of the object itself, and VB is the volume of the entire object. So these are the minor things that we need to aware of. Okay, uh, that gives us buoyant force because both the forces are if the object have buoyant force greater than the weight, then it will float. If the buoyant force is less than the weight, it will sink. So it is very much important that we know how to convert mass into density times volume, and which volume we need to consider. That is also need to be clear. Okay. Then one last force we will talk about is spring force. So spring forces. The Hooke's law says that the force applied by the spring on the object is directly proportional to the extension of the spring, and the proportionality constant is the k. K is nothing but spring constant. An extension of the spring can be calculated by if there is some original length and there is some kind of a extension because of the force applied. So that is equal to L minus x is equal to L minus L naught. Okay. So this is a spring force that we are going to talk about. Then uh, apart from this, we are going to talk about the equilibrium as well. So equilibrium is when the net force acting on the object is zero. Newton's first law. Equilibrium is achieved when the object is either moving at a constant speed or it is stationary, where all the forces are balanced. How do we solve any forces related problem? I always break down the problem statement into three steps. First, draw a free body diagram. The free body diagram gives us the forces acting on an object. Okay, force experienced by the object we have to always consider, not the forces experienced by the other object or the object of itself applying force on other object. We don't have to consider that. Second, so if there are two objects in the question, always draw two separate free body diagrams. Then this second step is optional, is it is not required in every case. But in this case, if we need to resolve any forces, the forces which are not parallel or anti-parallel or perpendicular to the direction of the motion. Okay, and this is very much important. So most of the time, students get confused which forces to balance and when. So we need to always be sure that any force, if there is a particular direction of the motion and if there are parallel and perpendicular forces, don't worry about resolving them. But in this case, like for example, if I have a force, like if this is the direction of the acceleration and this is a force, I don't need to resolve. Even the forces which are in opposite direction, we don't need to resolve all those forces. So that is completely normal. But if there is some kind of a force like this, which is neither parallel or perpendicular or to the direction of the acceleration. In that case, we will need to resolve this, and then this component will add p cos theta in this direction and p sine theta in this direction. So that is very much important. We need to aware of when to resolve the forces if there any force that is not parallel or perpendicular to the direction of the motion. So it is up to us which axis we need to choose and which forces to have. According to that, we can build our equation of the motion. So purpose of the previous two steps is to in the direction where the forces are not balanced. So we always break down the forces in vertical and horizontal direction. So in the above case here, the vertical forces have to balance because the motion, there is no acceleration in that direction. So vertical forces will be balanced. Why? The forces in the horizontal direction, like F minus, the forces opposite is frictional force minus P cos theta. So these are the forces that are in the opposite direction. So I will take a negative for them, and then that has to be equal to mass time acceleration. So this is the net force. Okay. So this is very much important to understand that if the forces are balanced in a particular direction, we will take them equal because the forces are balanced. And if there is not balanced in a particular direction, we can take the net force is equal to mass time acceleration, and it can be taken in both the direction. And ax is the component of the acceleration in horizontal direction, and ay is the component in the y direction. Okay, we don't need acceleration in two directions. Most of the time, we align our axes such that our forces are aligned in the direction of acceleration. Okay, we will see that in a couple of examples. Okay, so in this example, what we are going to do, see this quickly. So if there is a mass, there is a pulley. This mass is accelerating upward, this mass is accelerating downward, and m2 is greater than m1. But initially, they were both at rest, and we have to find the acceleration in terms of m1, m2, and m3. So in this case, what we will do, the vertical forces is tension and m1g. Now here we have to draw, while drawing the forces, always draw the vertical force. If it is accelerating in that direction, the vertical force will always be longer. Okay, so T is greater than m1g. So it indicates that the net force is T1 minus mg. Like it has to be the net force in that direction, and it is equal to mass time. So whenever taking mass time acceleration, you have to take the mass of the object whose free body diagram is causing like this equation. And then similarly here m2g minus, because it is downward, so m2g is greater force, so m2g minus. So where our purpose, whenever you experience a forces related question, instead of like thinking of what to do in this particular question, always rely on building the equation of the motion. Like this is what we call as equation of motions. Okay, once you achieve the equation of the motion for any situation, you don't know whether the force, like how the equations are related or anything, and how it will give you the final answer. Don't worry, just get the equation of the motion and then start thinking like how you can mathematically achieve anything asked in the question. So in this question particularly, they are asking acceleration in m1, m2, and g as a term. So we don't need tension. So what I can do, I can add those two equations. Once I add those two equations, what will happen? The t will eliminate, and then I can just simplify this. do some algebra to get my final answer as an acceleration. Okay, so this is what is required. 3 steps approach: draw the free body diagram, write the equation of the motion. Okay, and then third, do the algebra required as per the question. So we will say another example that there are two masses like this. Small m is greater than a capital M, and then we have to find the acceleration in this case. So in this case, if it is a frictionless surface, then there will be only horizontal force acting, that is the tension, and the vertical force is normal force and the weight. Okay, so in this case, horizontal acceleration is there, so vertical forces must be balanced, and the horizontal force is the tension, the only force. So tension is equal to mass time acceleration. That is the force, net force is equal to mass time acceleration, gives us for this object. Similarly, for in this case, the mg is greater than the tension, so mg minus tension is equal to ma if it is accelerating in that direction. So see, if there is one string, both the object will accelerate in the same direction, accelerate equally. So that's why the acceleration is same in both the scenario. Now our job is to eliminate the tension. So what I will do, I will substitute or add both these equations, and I will get something like this. Okay, so this is how we build any particular quantity if we need it in a particular question. Okay, another example I have, like there is two objects of 3 kg and 2 kg attached with the string. Okay, now in this case the forward acting force is friction. We need to calculate a friction tension between the string. So I can again draw the free body diagram. Okay, check out the vertical forces. This is a frictionless surface, so no backward force. Now there is a one string only, so this has the same tension that this object is X is experiencing, and then there is a normal force. Okay, now vertical forces are balanced, they are not influencing any horizontal motion since there is no friction. And we can write T is equal to 3a, 3 is the mass of this X, while F minus T, 2a. Okay, so F is given as 15. Now T we can substitute here, we can get F is equal to 5a. Okay, and once the A is equal to F by 5, we will get 15 by 5 is equal to 3. Okay, so what I'm doing is just substituting T value in this first case and then getting this acceleration to be equal to 3. Once we get the acceleration to be 3, the tension is equal to 3 into 3, that is 9. So this is how we can easily do it. Okay, another example is like if there are both strings, same kind, again free body diagram. Now on the X object, there is a weight plus a tension downward, while for the block Y, there has to be T2. Now you can see that there are two strings. So T1 is a string upward and T2 is a string downwards. And you can see this, the string, same string, so same tension. And this is the weight. Okay. Weight is already given for each object. So we can just substitute. Now forces are balanced in this case. So we can just substitute and we can equate them and we will get the answer. Okay. For the inclined plane, what happens again? Now 3-step approach I need to do. Okay, let's say I want to find the acceleration. So first step is to draw the free body diagram. In the free body diagram, I'll draw the weight first, then I have the normal force. Let's say this is a frictionless surface, so only two forces, and in this direction there is an acceleration. So what I need to do is, if this is the direction of acceleration, normal force is perpendicular to the direction of acceleration, while the weight is neither parallel or perpendicular to the acceleration. So what we need to do, we need to resolve it. So I resolve it into two components. One is W cos theta, which is along the theta. If you know this is theta, then this component is theta by applying some geometry. And this is the W sin theta. So W sin theta is the component along the slope. Okay, component of the weight along the slope, and that is W sin theta. So in Y direction, like I can choose my Y direction and X direction as per my direction of the motion. So in the Y direction, the net force has to be 0 because there is no acceleration. So in the vertical direction to the plane, perpendicular to the plane, so both the forces are balanced, like normal force and the W cos theta. So I can write normal force to be equal to mg cos theta. Similarly, in X direction, where the object is moving, there is some kind of acceleration, and only force acting is W sin theta. So we will get mg sin theta is equal to ma, and mm get cancelled to get acceleration to be equal to g sin theta. Okay, what if the object is stationary? The object can only be stationary due to some kind of static friction. So in this case, W sin theta is balanced by F, while the W cos theta is balanced by N. Okay, so N can be written as mg cos theta, while in X direction the forces are balanced, so friction is balanced by mg sin theta. Friction itself can be written as coefficient of friction times N. So coefficient of friction, if I substitute, and n is mg cos theta, so we can equate both of this, and what will happen? The mg will get cancelled, and we will get coefficient of friction is equal to tan theta. If I divide, sine upon cos is tan. Okay, so what does this help us? This is for which block remains stationary. So this is a max angle for a given coefficient of friction. So the angle at which the object can remain stationary depends on the coefficient of friction, and based on that we can calculate this. How does formula came into existence? Again, three steps process: free body diagram, equation of motion, resolving the forces. All these three steps helps us this. One last example I can give you: if the object is accelerating in the downward direction along when even if there is a friction. So in the vertical direction, the forces are balanced. So I can equate n is equal to mg cos theta. Okay. While in horizontal direction or in the direction of the motion, W sin theta is greater force and the friction is dynamic friction in this case, and that is equal to mass time acceleration. I can substitute this part as it is, friction as mu d n, and n can be written as mg cos theta, where we get get cancelled on both the side of the equation. We get acceleration to be sine theta minus mu cos theta. So this kind of equations are building. You don't have to remember anything, but you have to learn the skill to build such kind of equation based on the Newton's law. You have to ask whether the object is accelerating in that direction or not, or if it is stationary. And if it is stationary, if there is some kind of a friction involved or not. And then always remember to follow the three steps. Okay, we'll see more examples of this in circular motions as well. But for this video, that's it. Thank you so much.